Okay, is it recording? It is recording. Okay. All right. Does anybody think they have the answer to this? You think you have an answer? Does anyone else have an answer? You think you have an answer? Okay. You think you have an answer? All right, what we're going to do, see if we can see this here. There cannot be half a pencil. How could there be half a pencil? No. No half a pencil. Okay. All right, so if you see this activity, we have, and I'll do it the way you have it. You have 3 pencil boxes, right? 3, these are like my pencil boxes. And then we have 2 pencils, and these little black cubes are going to be my pencils. Okay. So I have 3 pencil boxes and 2 pencils equaling, heaven help me. Well, not equal. Why is it not equal? 3 pencil boxes and 1, 2, 3, 4, 5, 6, 7, 8. Why is this not balanced? Of course, this isn't going to work. Like, it's way too complicated. It worked until I switched the sides. Shame on me. So this is balanced. Is that balanced? No. Still not balanced? 1, 2, 3, 4, 5, 6, 7, 8. All right, let's just move it back. Now is it balanced? Yeah. Okay. All right. All right. So this is backwards, so we can turn it around so it's facing you. Because we're going to physically emulate what's happening here. Now, you can use algebraic operations and opposite operations to solve this problem, or we could do it physically, okay? So what it's saying is that you have 3 pencil boxes and 2 pencils equaling, weighing the same as 2 pencil boxes and 1, 2, 3, 4, 5, 6, 7, 8 pencils, okay? Now, if the point is to figure out how many pencils fit in each of these pencil boxes, ultimately, I need to have a pencil box on one side, and I need to have just pencils on the other. That would tell you how many pencils are in a pencil box. Isn't that true? Now, if the 2 sides are equal, the 2 sides of the scale is balanced. The point is, we have to do something to each side. I like that. We have to do something to each side, but we have to do the same thing to each side to keep the 2 sides balanced, to keep the equation, the 2 sides equal. Okay, so can somebody tell me how they did this? 1 step at a time. What did you do?
I started off by making an equation.
Oh, you made an equation. Okay, let's go ahead and do that. What was your equation?
So for the pencil boxes, I used a variable. I just put P.
You're so fancy. So you said, okay, I'm going to call my pencil boxes P. Fair? Does everybody see how we're doing it this way? This is one way to do it. Okay, keep going.
So then, since there's 3 pencil boxes on one side, I did 3 P. There's 2 pencils. I added 2. And then I say, since it's balanced, I put the equal sign. And then there's 2 pencils, so I put 2P plus 8.
Out of curiosity, who wrote an equation? Okay, you don't have to do it that way. Ultimately, that is how we're going to do it. If we are trying to figure out the value of the pencil box, how many pencils fit in the pencil box, then we are going to assign the variable to be that. But I didn't expect you to do that just yet. Instead, I'm looking at this, and then what would we do? If we want to solve for the value of the pencil box, what would we remove from either side first, from both sides?
2p.
You want to take away 2p? Okay, so that means I'm taking away 2 pencil boxes from one side and 2 pencil boxes from the other. Does everybody, do we see how we did that? It's still balanced because I took the same thing off of each side. Algebraically, how would I do that? Let's go ahead and write this over here and work out the steps. So if we took away 2 pencil boxes from each side, algebraically, how would I show that?
You would take the 2, you subtract 2p from 3p.
Right? We took 2 pencil boxes away from each side, didn't we? Okay, so what do we have left? On this side, what do we have? 1 pencil box and, no, 1 pencil box and still 2 pencils, right? Equals 8 pencils. Do you see how we're keeping it balanced? Yes.
Do you have to, 2?
Well, what would you rather do?
What?
Well, I mean, ultimately, we need to know how many pencils are in the pencil box.
Do you try to cancel out one of them?
Ultimately, yes, because ultimately we want P to equal some number. That's what we're trying to figure out. How many pencils are in the pencil box? So did you have to start by subtracting 2P? No. Eventually, you do want to remove those 2 pencil boxes. So now I want to know how many pencils are in this little pencil box. So what could I do to each side now? I'm going to subtract 2 of the little black cubes, right? And I shouldn't write that. So if I took 2 black cubes away from here and the same thing from the other side so it stays balanced, and boy, you know, this is testing this. It's not exact because, you know, these are pencil boxes and pencils. But then now what do I have on the left side? 1P. And then how many little pencils or cubes do? 6. Who got 6? Did we do it a different way? How did you do it? You counted how many pencils were on this side. So you took away the pencils first.
8, and then there was 2 on the left side, so I just subtracted 2 here.
So you subtracted the pencils. Okay, let's look at it that way. That is valid. Well, you know, let's do it that way, right? Okay. Yes. Yes. Well, it depends how complicated the equation is, right? But you're saying that you said you had 2 here, so you took 2 away. You took 2 away. Okay, I'm going to do that. I'm going to take 2 away from this side, and I'm going to take 2 away from this side. So now what do I have left? I have 3 pencil boxes equaling 2 pencil boxes and 6. Then what?
For 3 pencil boxes by themselves equaling 2 and 6, that means there would have to be 6 in pencil boxes.
But how are you getting that?
You cancel out.
You cancel out the pencil. You remove the pencil boxes from either side. So it's the same thing. You did the same thing. You did opposite algebraic operations. That is absolutely correct. What I wanted you to recognize with this example here is that we have 2 algebraic expressions, whether you write them numerically at, you know, with variables and constants, but we have 2 expressions on either side that we're saying are equal. We have to do something to each side of the equation, but if you do it to one side, you have to do the same thing to the other side, or it's no longer equal. It's no longer balanced. So that was the whole point. The whole point is to visualize this. So in the back of your mind, as we start solving these equations, you keep in mind that if you do something to the one side, you have to do the same thing to the other side, or it's no longer balanced. Okay, so that was the point of showing you this. Whether it helped or not, that was my point of getting these cute little things here. So we shall continue. Yes, any questions? Nope. All right, so let's continue on with the notes. If we continue on, we solved this algebraically. But the point I wanted you to recognize is that we have an open sentence. So this is a sentence, right, that contains two algebraic expressions. So this is one algebraic expression. That's the other algebraic expression, and a symbol that compares them. In this case, I'm saying that the two are equal. Okay? So this is what we call, in this case, an equation. An equation is an open sentence that contains an equal sign, saying that the expression on the left is equal to the expression on the right. So let's look at this example. A little math sentence. In 15 years, Agnes will be 25 years old. A is the variable that is going to represent Agnes's age today. So she's 8 years old today. In 15 years, she will be 25. So if I want to write that word sentence, that open sentence, as an equation, we first read the problem. We identified the unknown value, which was A. Okay, so A is the unknown value. We assign the value variable A, and now we have to express all quantities in the problem in terms of A. So if I want to write two equivalent expressions connected by an equal sign, how would I solve for Agnes's age today? Does anybody think they know? That is absolutely correct. Her current age is A in 15 years. So today, Agnes's age A plus 15 years from now will equal 25. Can everybody see how B is the correct representation of that open sentence? If not, speak up. We're okay? All right. So let's talk about some other open sentences, some mathematical equations. Pavel has a dog. Pavel's dog is 5 kilograms heavier than his cat. So he has a dog and he has a cat. The dog is 5 kilograms heavier than the cat. Both pets, meaning the dog and the cat, if I say and the cat, what operation is that? Addition. So the dog plus the cat weighs 13. So do you see, first of all, how the weight of the dog plus the weight of the cat equals 13? Right? Now, how are we going to think about this relationship here? If the dog is 5 kilograms heavier than the cat, which weighs more, the dog or the cat? The dog. The dog weighs more than the cat. So I'm just kind of keeping that in mind. How much more does the dog weigh than the cat? 5 kilograms. So let's think about how we can introduce variables. Well, I let D equal the dog. Oh, but they didn't say let D equal the dog. I see Y's. I see Y's. What does the Y represent if I give you this equation? Bless you. The dog or the cat?
If the dog
Okay.
can you do that?
What do you mean, can you do that?
Like, can you, for two separate, can it both be?
Yeah, because I'm writing the dog's weight in terms of the cat. Okay, so the dog's weight is 5 more than the cat's weight. Does that make sense? If I'm reading those those words, I can turn it in to equations or expressions like we did yesterday. So the dog's weight is 5 heavier than the cat's weight. So now let's think about that. So that means one of these is the dog and one of them is the cat. It's the dog and the cat. But one is the dog is one and one is the cat. So what does the Y represent? That is absolutely correct. So Y would represent what? Y represents the cat's weight, right? Y represents the cat's weight. And if I ask how much does the cat weigh, then I can solve for Y. So cat's weight is Y, dog's weight is the cat's weight plus 5. So therefore, the cat's weight plus the dog's weight equals 13. So how much does the cat weigh? Well, let's take this equation and let's solve for Y. If I look at just the left-hand side, I can drop the parentheses and combine like terms.
Are you allowed to change the variable?
Well, they've assigned the variable, so we don't really want to. I would choose D and C, but you know, they gave us Y. We have to play with their variables. So how could I combine like terms on the left-hand side? How could I rewrite the left-hand side of the equation? Okay, so Y plus Y is 2Y. Excellent. Now, keeping in mind, just like we did with the scale, we have to keep the two sides equal. So what can I do to each side of this equation? I am going to take 5 away from the left side. I'm going to take 5 away from the right side. 5 minus 5, that's 0, right? Positive 5, negative 5, sum to 0. So what am I left with? I'm left with 2y equals, and what's on the right-hand side? 8. Now, I want to figure out what y is. What is y? Well, what's standing in the way of the y being by itself?
2.
The 2. What operation connects the 2 and the y?
Multiplication.
Multiplication, right? This is 2 times y. The coefficient is 2. The variable is y. It's connected by multiplication. What is the opposite operation to multiplication? Division. So what can I do to address this 2 here?
Divide by 2.
Divide by 2. Divide by 2. Now remember, you do it to one side, you better do it to the other side, or the two sides are no longer equal. Okay? So if I divide the left side by 2, I have to divide the right side by 2. A number divided by itself is 1. So what do I have on the left-hand side? Well, on the left, y. On the right, 4. So what does that represent? The weight of the cat. So the cat weighs exactly. So to get the dog's weight, we take the cat's weight, which is 4, add 5 to it since it weighs 5 pounds more, or 5 kilograms more. So the dog weighs how many? Right. 9 kilograms. So since these are word problems, you would write your answer in sentences and you want to make sure you include your units of measure. In this case, it's kilograms. How are we on that one? Oh, I'm bad. Okay, let's try another one. Sini got 11 points on her math test. 2 points for the first question and 3 in each of the remaining questions. How many questions did she earn 3 points on? So the total points on the test, let's write down what we know. The total points on the test is what? 11. Right? Now, she got 2 points in the first question. So for question 1, she got 2 points. And then she got 3 in each of the remaining questions, but we don't know how many more questions there are. So we have to introduce a variable. Yes. That's absolutely correct. We know there's total 11 points. She's already earned 2 points, and then for every additional question, she earned another 3 points. So for 1 question, she earned 3 points. For 2 questions, she earned another 6 points. Can we get this equation? Yeah. Okay, let's see how many questions she earned 3 points on. How would I solve for X? Okay, do the same thing to each side. This sums to 0, leaving me 3x equals what? 9, and then I'd still need to isolate the x, so what would I do to each side? Divide each side by 3, and then x equals 3. So she earned 3 points on 3 questions. Okay, let's think of the next one. 3 children had 11 pieces of chocolate. Sounds like Halloween. They each got the same number of pieces, but then 2 pieces were left over. How many pieces of chocolates did each child get? Okay. Anybody agree or disagree with that? How many pieces did they have total? 11. So whatever we do, we're going to end up with 11 pieces. Now, 3 of the children shared some number of pieces. It is plus 2. So there's 2 pieces left over, plus the 3 children sharing some number of chocolates. We see how to get this equation. Okay, I need to solve for the number of chocolates. I'm going to subtract 2 from each side, which would give me 3x equals, so x equals, oh, imagine that. So there were, or I should say each child got 3 pieces of chocolate. I don't know, you're going to tell me. Joelle has 11 pets. She has 2 dogs, 3 parrots, and some number of cats. The total is 11 pets. So how would I write an equation to find the number of cats? So that would be C plus 5 equals 11, right? Because the dogs and the parrots, we don't have to separate those. They're just other animals. So what would C equal? C would equal 6. There are 6 cats. So given verbal written words, you should be able to turn those into equations and answer the question, which of these 3 stories match the equation 3x plus 2 equals 11? I am saying that this one was this equation, this one was this equation, this one was not. So just A and B. Shall we write more equations? Of course we shall. Jen bought 2 more apples than oranges. Does she have more apples or more oranges? Apples. So the number, I like, for me, just apples are more than oranges, just in my head. So it makes sense at the end of the day. I should put, let me put oranges as R, because that looked like a 0, and that might be confusing. She bought 12 pieces of fruit in total. If she bought only apples and oranges, which of the following equations could be use to express this story? And then we'd have to figure out what the variable represents. She bought 2 more apples than oranges. Anybody have an idea? It would be A. So the number of apples plus the number of oranges equals 12. What would X represent? The number of oranges. How many oranges did she buy? Well, we would solve the equation. So if I take X plus 2 equals 12, let's combine like terms on the left-hand side. Does everybody see how I combined the X terms, those like terms? And then if I'm trying to isolate X, I'm trying to solve for the value of X, what would I do to each side? Subtract 2 from each side, keeping the 2 sides of the equation balanced. So this goes to 0, leaving me 2x equals 10. And then what would I have to do next? Divide each side by 2, so x equals 5. So how many oranges did Jen buy? Jen bought 5 oranges. So if we know she bought 5 oranges and she bought more apples than oranges, in fact, 2 more apples than oranges, how many apples did she buy? Jen bought 7 apples. Make sure that this says apples on your sheet, because I know there was a typo and I correct. Okay, change it to apples. So make sure you change that, or else we're answering the same question twice. All right. Yes, absolutely. You have won a shopping spree from 104K RBE. Currently, you have $1,500 and you spend your money at a rate of $55 per hour. So you're starting with $1,500, but every hour you spend $55. So which expression would represent that? We start with $1,500 and we take away $55 for every hour. C. If we want to write an equation that represents when you have no money left over, what would the equation be? We start with $1,500. We spend at a $55 per hour rate. When does that equal 0? So how many hours, what would we do? Okay, so you want to move this to the other side. Is that what you did? It sounded like that. You said 50. Okay, y'all want to take away the 1,500 instead? Okay, we can do that. They're both correct. They're both correct. As long as you do the same thing to each side, you can move things back and forth for the rest of your life if you're not clever. Okay, so you said you wanted to subtract the 1,500 from each side. Okay, 1,500 minus 1,500 is 0. So what's left on the left-hand side? Minus 55x, right? Right? Because there's a minus sign here. Don't lose it. And what is on the right-hand side? How much? You are absolutely correct, Miles. That is fantastic. Now we keep on going. I need to solve for x. What's standing in the way of the x being by itself? That negative 55, how is it connected? By what operation? So what's the opposite operation? Division. So I'm going to divide this side by negative 55. I got to keep the 2 sides of my scale balanced, so I've got to do the same thing to each side. Now, if you take a number and you divide it by itself, what does that simplify to? 1. Okay, so I have just 1x, and then negative 1,500 divided by negative 55 is what? Anybody have one of those little calculators to, to do the arithmetic? Yes. Negative 1,500 divided by negative 55. Huh?
27.
Is that correct?
27.27.
That's what I.
Is that correct? Yes? Do I trust you? Well, yeah, but it depends on whether you put the right thing in the calculator. You said how long? 0.77?
27.
27.27 repeating. So it takes, and I'm going to say approximately 27 hours to spend it all. It's craziness. Who knew? Okay, let's try this one. You decide to open a Sprinkles cupcake shop. Your initial startup cost is $80,000 for the supplies in the building. And once you open, you make $12,000 a month. We want to first define a variable for the number of months and then write an expression to represent your profit based on the startup cost and how much you make a month. Anybody have any ideas as to how we can introduce a variable? So, okay, well, let's define variables first. So we have the number of months, right? So maybe let M equal the number of months open. Is that fair? And then I'm going to let P equal the profit. And I want to write an expression that represents the profit based on the startup cost. So the profit equals what? $12,000 a month, but then we have to take into consideration that we had to pay to start the business. So we have a profit of $12,000 a month, but we spent money already. So how would I represent the fact that I had a startup cost? Don't I have to take that away from my profits? Yeah. So I'm in the hole at $80,000 before I even open the store. I had to buy supplies in the building. But then I make a positive $12,000 for every month. So that's how I would represent my profit. So this is my little expression that represents my profit. Now, if I want to write an equation to determine how many months it'll take you to recoup that initial cost, when will you actually start making money? Anybody have any idea how I would figure that out? I want to write an equation. When will I start? When will my profits?
Like 12,000 divided by 80,000.
So I'd say $12,000 per month has to equal $80,000. Right? Before I start making any money, I have to zero out, right? I have to get back what I spent. So once I set this equal to 0, I can solve for the M, the number of months it takes by making this every month to make this amount. Then I'll start earning money. So I technically could set this equal to 0 and solve for when I start making money. So if I set this equal to 0, I can move this to the other side by adding 80,000. So how am I going to solve for M? I am going to divide by 12,000. Now, if you don't want to deal with all those zeros, remember for every, this becomes 1, leaving me M, and then I can keep dividing by 10. So this is literally 80 divided by 12, which is what?
Mhm. 6 point, I don't think it's even. I don't think 12 times 6 is 80. I think it's 72, so it's 6.6 repeating, right? So it will take approximately 6.7 months until I start making a profit. Does anybody know what time we get out today from this class? 45? Okay. If you notice from yesterday, did y'all finish those two problems? Did you look at those on the completed notes? Those were the last two problems that I left you with. Okay, so if you can't do those, I recommend coming to tutorials, looking at the completed notes on Canvas and make sure they make sense. We have meaty mystery that we need to finish if we haven't finished over the weekend. And we also have where do they go, placing the parentheses. I highly recommend that you catch up on anything that you have not completed, because come next week, you're going to have to turn those things in. Oh my goodness gracious. Snotty.